Hi everybody. One of the things that I find really hard in lockdown is actually that I can't actually sit and teach you and look at you in the face and teach you some of these new and different things. So I thought that today and for this week that I would actually do a lesson like you would normally see me do it in class. So as you know, when we've been looking at our unit of inquiry, we're looking at forces. And last week you were asked to look at how do we actually make a scientific experiment. How do we hypothesize, or how do we think about what might happen? How do we make it fair? And the other thing is, what are the variables? What are the things that can happen that can actually change the outcome of the experiment that you are putting together? So today we are going to have a look at gravity. So the force of gravity, the thing that keeps us on the earth. The two forces, so there's ourselves and the force of gravity, and the earth beneath us, and how we are all being able to stay together. Now, one of the best ways to show that is with water, and also water is good fun to play with. So we're going to do a gravity experiment with water. So what you're going to need is a plastic cup and a pencil, and you're going to need some water. And we are going to have a look and see how gravity affects the flow of water. So the first thing we're going to do is we're going to take our cup. Now, one of the things that I found a little bit tricky when I was actually putting a hole in my cup is that I pushed too hard. So you might be able to see that I made a big hole in that. So that would be a variable, wouldn't it? So if I had a really neat hole in this one and a really ugly hole in this one, we might be able to see what the difference might be. So I'm going to take my pencil and I'm going to make a hole right here, just down in the bottom here with my pencil. I'm going to do it pretty quick. See if I can do it properly this time. Oh, here we go. You guys would have waited. Oh, look at that. So I've made my little hole there. And so if you were going to hypothesize what was going to happen when I put the water in, I think you would probably say that the water would come out of that hole. Yeah, I think you'd be probably right. So I'm going to come over here to my sink, and I'm going to fill my little Pyrex jug up. This, and now the reason I'm going to hold it over a sink is because I don't want to flood. So, and I know that your mums and dads won't want to flood. So if I was going to hypothesize what was going to happen, I'm going to pour this in, the water in. The gravity is going to help force the water down into the bottom of the cup. But because there's a hole in the cup, that water is going to come out of that hole. So let's have a go. So if we pour it in, here we go. And there it is. There's our water coming out of our cup. Because the gravity is forcing that water down, because and the water is trying to find the quickest way it can get to the earth. I stop that though, because my finger is actually strong enough to stop the flow of that water. Take it off again, and it still comes off again. Now, the interesting thing with this is, what do you think would happen if I dropped it from a height and let my finger go at the same time? Now that's the really interesting thing that happens with this, and this is how we can really show the effects of gravity. I wish I could be a mystery Doug, but I'm not quite a mystery Doug, and I'm very grateful because I've got Isabella filming me. So we're going to have a go. We're going to start with it up here, and then I'm going to drop it, and I'm going to see whether the water starts coming out at the same time, like it did when I took my finger off. Are you ready? 1, 2, 3. Now, that didn't work very well, because what happened was that the cup fell over. However, if we had a look at it in slow motion, what you would see is that with my finger coming off and the cup coming down at the same time, the forces are equal, and therefore gravity would not allow for our cup to actually lose its water through its hole. And so this is called a water gravity drop, I call it. So it would just drop down. If I drop it down, I just get splashed, but the water doesn't actually come out of the hole because the forces are exactly the same. So another experiment that you can do is to get a glass jar, and you can fill this glass jar up with water, and I'm absolutely positive that some of you will have done this before. What I've got here is a little piece of card, just a little piece of card, and I'm going to stick it over the top of my jar. And I'm going to flip my jar over. Now what you can see here is you can see a gap, which is at the top here. Now this gap is an air gap, which is actually going to cause something called a vacuum. So although the water is desperate to get down with the gravity, the vacuum is forcing it back up, and it's getting where the water line meets the big air gap. We've got something called tension or water tension. So if I hypothesize with that, I've got an equal force going up and an equal force coming down. So therefore I hypothesize that when I take this off, ta-da, my card won't come off, which is pretty cool. So that is why you can see if that forces are equal, that they stay. However, check this out. If I take this off, we lose all that water again. Now another experiment that I have been working on too is how can we use something like a Chuck's cloth, and as you know, a cloth like this has lots and lots of holes in them. Okay, it's got lots of holes in them, and we use these, and that allows the water to get through these holes. So you can see, you can stretch it, you can do whatever you like with it. Now, using this, what I'm going to do is take my glass, and I'm going to pop it upside down. Just remove all those other things away so that you can see what I'm doing. And I am going to make a circle going around. I'm going to make it bigger than my glass jar. So I'm going to make it much bigger than my glass jar, and around I go, round, 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 round. Then what I'm going to do is I'm going to cut out that circle. So using Mrs. Powell's very blunt kitchen scissors, I am going to cut right the way around my circle. Right the way around, right the way around. And I wonder whether I'm going to be able to do the same experiment that we've just done, but with something like this that has holes in it. So here I've got my lovely piece of holy fabric, and I can see you through that, and I'm going to place it over my jar like this. Here's one I've done before because I had to practice. Just like Mystery Duck, I had to practice because I wasn't going to do something that didn't work. So what I'm going to do is I'm going to take this off, and I'm going to pop it around my jar like this. Pop it around my jar, and I want to make sure that it's nice and tight. So you might need mum or your big sister or brother to help you with this bit. I know this is probably the trickiest part of this whole experiment, is making sure that we are putting our rubber band on to make it nice and tight. So there we are. We've made it our jar nice and tight with our things on top. Now, if I was going to hypothesize, because it's got holes in it, if I was going to pour water on that, do you think the water would stay on the top, or do you think the water would go into the jar? Wonder what you're saying. I hope that you're all saying, well, Mrs. P, it's got holes in it, so of course water's going to go through it. So let's come back to my little sink here, and I'm going to start filling my jar with water. And you'll be able to see that although it's not filling very quickly, I can see that my jar is filling up with water. So there's my jar, and it's filled with water. Now, I'm going to tip it upside down, and the water is going to start to come out. If I shake it like this, the water is going to come out because of the holes in the cloth. Now, can you remember what that word was when we practiced, when we did the one without the piece of cloth on there? And it began with a V. It was vacuum. So when we had the vacuum at the top, and the pressure at the bottom, and the gravity pulling it down, but then also the water tension, this was able to stay on the piece, on the glass. So we're going to try this again. So I'm going to tip this upside down, like this. Now I wonder what you think or hypothesize is going to happen if I take this away. I wonder. I wonder whether the water is going to come out of my glass jar. So I'm going to take this carefully away and check that out. Now I wonder why this happened. I wonder if you can tell me why you think all of a sudden the magic of science is stopping the water from coming out of this jar. Well, my lovelies, that was our science lesson for today. So I'd like you to have a go and see if you can show me how you can do a simple experiment like this at home. The other thing you can put in there is some food colouring. That makes it a little bit more exciting. What variables could you add? Is it different with a smaller jar? Is it different with a plastic cup? Show me what type of different variables you could use, the things that would make it different. Is it different with hot water than with cold water? So this is an opportunity for you to go and have a little bit of a play now and see what sort of experiment you can come up with. I look forward to seeing you all for another Science Time with Mrs. P. See you soon.